Welcome to the deep dive. Today we're jumping straight into high-performance mobile subwoofers. We've got a whole stack of sources you sent over, digging into the physics of bass. So our mission today, break down that engineering stuff, the metrics, into what actually drives sound quality, especially thinking about places like Trinidad and Tobago, where the enthusiast scene is really demanding.
Yeah, exactly. And what's really interesting, when you boil it all down, every bit of performance, whether you want that super crisp sound or just crazy loud competition output, it all comes back to one core thing. How well the motor turns an electrical AC signal into physical movement. It's all electromagnetism, really.
Okay, right. So let's unpack that. How does the electricity actually, move the cone?
Well, you got the motor structure. There's the permanent magnet that's fixed. Then there's the voice coil. Now, that becomes an electromagnet, like a temporary one, when your amp sends current through it. That current makes the coil's polarity flip back and forth really fast, so it's constantly attracted and repelled by the fixed magnet.
And the cone just gets pushed and pulled by that action.
Exactly. The cone is basically the piston pushing the air, creating the sound waves, and the single most critical number in this whole dance, that's the BL factor, the electromagnetic force factor.
BL factor, okay.
Think of it like magnetic grip. It's the one number that tells you how good the motor is at turning electrical current, amps, into physical force, measured in newtons per ampere, or sometimes you'll see Tesla meters, TM.
Okay, magnetic grip. So why is having a high BL, a strong grip, so important for the actual sound quality, the precision?
Because a high BL gives you the force needed to accelerate the cone's mass really quickly.
Yeah.
But just as important, it lets you decelerate it, stop it just as fast. That control, if that's your transient response, how fast and clean the sub starts and stops on a kick drum hit.
Right, tight bass, not sloppy.
Precisely. Without that strong BL, that strong control, bass just gets muddy, kind of bloated, loses definition.
Okay, that seems straightforward. But then looking at the sources, you flag something interesting with that SCAR SDR18 comparison. The D4 version had a BL of, around 10.7?
10.6 not, yeah.
Right. But the D2 version had a much higher BL, like 17.11, so stronger motor. But you said its damping was surprisingly worse. How does that work? Shouldn't stronger mean better control?
Yeah. That's where it gets tricky. That's a perfect example of these trade-offs. Yeah. We need to talk about Qs.
Qs.
The electrical damping factor. Think of Qs as the electrical brake slowing the cone down. Now, the D2 setup, yes, it gives you way more motor force, that high BL. But when you wire it that way, you actually double the electrical resistance of the voice coil.
Oh, okay.
And that higher internal resistance, the sources show this in the measurements, it kind of fights against the mechanical damping from the strong motor. So your overall damping factor, the Qs, ends up higher, which means less effective damping than you might expect just looking at BL. Classic engineering trade-off.
Makes sense. Okay, speaking of trade-offs, let's shift gears to the magnets themselves. Neodymium versus ferrite, that seems like a fundamental choice for buyers. What's the deal there?
Big difference. Neodymium, or NdFeB, its magnetic energy density is just incredibly high, which means you get a ton of magnetic strength from a really small, really light magnet.
So better performance, less weight.
Exactly. That makes it ideal for pure sound quality builds, where accuracy and saving space are key. You get that fast, transient response.
Okay, Neo sounds great. Smaller, lighter, more accurate. What's the catch? There's always a catch, right?
Yeah. Well, two catches, really. First, the figurative one. Heat tolerance. Neomagnets don't like getting hot. They can actually permanently lose magnetism, demagnetize if they overheat.
Yeah.
That's a big risk in high-power systems.
Ouch. And the literal cost.
Also high. Neodymium just much more expensive, which is why ferrite ceramic magnets are still so common, especially for high SPL.
The loud stuff.
Yeah. Ferrite has lower energy density, so you need a much bigger, heavier magnet for the same strength. But it's way cheaper. You get maybe 2 or 3 times the magnetic field for your money, and critically, it handles heat much, much better. So for those extreme SPL competition cars running insane power for long periods, ferrite's just more robust.
So neodymium for accuracy and space, ferrite for cost and taking abuse.
That's a good way to put it, yeah.
Okay, so bringing this all together for you, the person actually buying a sub, there's this whole myth about where things are made, right?
No, definitely. Look, the reality is the vast majority of raw speaker components, voice coils, cones, spiders, magnets, they're made in Asia. Period. True quality isn't determined by where the final screw is turned. It's determined by the brand's design, their engineering choices, and crucially, their quality control. Like Kicker using sophisticated Clipple analyzers to check every driver. That's quality control.
So when brands like, say, JL Audio make a big deal about assembling their high-end stuff in the US.
Often, that's less about generic quality and more about protecting proprietary designs, keeping really tight control over high-tolerance manufacturing for their top-tier stuff.
Gotcha. And looking at a market like Trinidad and Tobago, the sources show a really specific demand, don't they?
Absolutely. It confirms what many already know. There's a really strong, dedicated culture there focused on high sound pressure level. Serious SPL. I mean, you see shops offering extreme drivers, like that DD Audio 9912C. That thing's rated for over 3,000 watts RMS and costs nearly 10,000 TTD. That tells you the market demands serious power handling.
Wow, okay. That's a massive investment. Which brings up another point. Maintenance on these high-power systems must be critical.
Essential. Absolutely essential. For anyone investing in these high-wear, high-stress systems, you have to think about repairs. That means prioritizing authorized dealers, like Triple R Electronics you mentioned, or official JL retailers. Why? Because they stock the actual repair parts. The specific recone kits, new cones, voice coils, spiders match to that driver.
Right, you can't just slap any part in there.
No way. These systems run so hot, push so hard, things eventually wear out or fail. Having access to proper repair kits is key for keeping that expensive sub alive long term. It's not just about buying it, it's about maintaining it.
So, okay, wrapping this up. The key takeaway seems clear. Performance metrics like BL are crucial, they're quantifiable. But the real-world choice often boils down to materials. Neo gives you that precision and saves space, but costs more, and is heat-sensitive. Ferret saves money and handles abuse, but it's big and heady.
Exactly. It forces a choice based on your priorities, which leads to maybe a final thought for you to chew on. We mentioned high-end brands often keep some operations, especially for flagship lines, in places like the US to control proprietary designs. So here's the question. How much of the premium price you pay for those top-tier drivers really reflects fundamentally better engineering versus how much is just about managing or maybe mitigating neodymium's inherent weakness to heat? Something to think about.